Good morning, ladies and gentlemen. I hope you're having a great day. We're going to dive right in. You had a homework assignment that said 6 types of equations and inequalities quiz. And what we're going to do today is we are going to talk about 4 of those types of equations because they are all quadratic-ish. They're not quite quadratic equations. They're all kind of quadratic-ish. And the last 2 are inequalities, and we're going to wait to talk about those until Wednesday. But so for today, my hope is that you went home and you tried some of these problems, and you maybe dug through the book on section 1.7 and kind of looked at how to do some of these. And so what I'm going to do is 3 things for for the first 4 type of problems. Is I'm going to do the problem that was on your homework, and I'm going to do it pretty quickly. And then I'm going to do a second one that I'd like you to do along with me. And then I'm going to do a third one, except you're going to try it, and then I'm going to show you how to do it and make sure you did it right. Okay? So without any further ado, let's dive in. We got number 1. Looks something like this. It said x to the 4th minus x to the 3rd equals 6x squared. Well, like I said, these are all kind of quadratic-ish. And with quadratic problems, we always want to set them equal to 0. So the first thing we'd want to do is move everything over to one side. And when we do that, now we've got at least a trinomial. Now, what we're going to do is we're going to go ahead and factor out. We notice that everything has at least an x squared. And if we factor that out, look what we're left with. Here, now we have something times a very recognizable, very easy quadratic trinomial, something we can factor very easily. You know, you think about it, you go, we'd be looking for factors of -6 that add up to be -1, and that would easily be -3 and 2. So we can split that quadratic into those 2 things. So this x squared still floats out front. It's not like we can say, well, we're just going to divide that off. That's still there. But then this can become x minus 3 times x plus 2 equals 0. Now, we've done factoring similar to this before, but now all of a sudden we are looking at these problems and we have a solution. We have something equals 0. And so what we do is we go, well, this could be one of 3 cases. Either x squared is equal to 0, or x minus 3 is equal to 0, or x plus 2 is equal to 0. And if x squared is equal to 0, well, that just means that x is 0. And if x minus 3 is 0, that would mean that x would have to be 3. And if x plus 2 is 0, that would mean that x is -2. So there's really our 3 possible solutions. Someone could argue that there are 4 solutions. You know, we say, hey, this is raised to the 4th power, so there should be 4 solutions. And that's true. It's just 2 of them are 0. Since this says x squared is 0, that means that x times x is 0. So one or both of those x's could be 0. So there's your 4 solutions. And that always seems kind of odd, but that's technically how they're looked at. Okay, so let's try another one just like it. Very, very, very similar problem. Okay, and so I'm hoping by this point you have something with which and something on which to write, and you can jot down this problem, and we're going to walk through it a little bit more slowly, trying to think about how we would do this. Well, if it is a quadratic, we want to set it equal to 0, so we're going to push everything to one side. So I've got x to the 5th minus 7x to the 4th plus 12x to the 3rd equals 0. Okay, now all of them have at least an x to the 3rd, so I'm going to factor that out, and that leaves me with x squared minus 7x plus 12 equals 0. Again, really, really easy. We go, okay, when I see this 12, I'm looking for factors of 12 that add up to be -7, and that would be -4 and -3. So then I can take this and make this say x to the 3rd times x minus 4 times x minus 3 equals 0. And so really now those are your solutions. You have, think about what this x to the 3rd equals. That means that x times x times x is equal to 0, which is to say that one or all or some of those x's equals 0. That's one of the possible solutions. You could have x minus 4 is equal to 0, which would be to say that x is 4. Or you could have x minus 3 is equal to 0, so therefore, x could be equal to 3. So the 3 possible values that make this original statement true are that x could be 0, x could be 4, or x could be 3. Those are the 3 possible cases. All right, now that you've seen two of these done, I want you to try one. So here's the problem I'd like you to try, okay? X to the fourth plus 4x to the third equals 60x squared. It's just like the other two, should be very similar. You should be able to do this. So we're gonna pause the video right here and give this problem a shot, and I will work it out in about 90 seconds. Okay, let's see. Hopefully you were able to see that this one is not real hard. Just like all the other ones, first thing I want to do is bring everything over to one side. So I'm going to have minus 60x squared equals 0. I can factor out an x squared out of every term, which leaves me with x squared plus 4x minus 60 is equal to 0. I can factor this part right here. I'm looking for factors of negative 60 that add up to be positive 4. The two that I can think of would be negative, let's see here, negative 6 and positive 10 would add up to be positive 4, but would multiply together, give me negative 60. So I get x squared times x minus 6 times x plus 10 equals 0. So therefore, either x is 0, either x minus 6 is 0, which would mean x is 6, or x plus 10 is 0, which means that x is equal to negative 10. So hopefully these are the three solutions that you got. And if you did, congratulations. These are not that hard. Okay, so the first type of equation is a quadratic-ish problem, but we notice with all three of them is that the powers are just higher than they need to be, and so in all three cases, we were able to factor something out that then in the end made the rest look like a basic quadratic trinomial, okay? So that's the first type of problem. It's got too many x's, so we factor that out, and then we can simplify, solve the whole thing. Okay, the second type of problem. The second type of problem are going to be called problems or equations involving radicals. Okay, equations involving radicals. Now, first quick glance at this, and this does not look like an equation that maybe we know how to solve. It looks too complicated, too ugly, too weird. But good news, it's actually really simple. Okay, so the first thing you want to do is you want to get rid of this radical. And we can do that by simply squaring both sides. Now we know that when I have x plus 2 and I say squared, that never equals x squared plus 2 squared. That's never true. But if I have a radical of x plus 2 and I square that, well, this is one time where the radical and the exponent cancel out. And so that would equal x plus 2. Now I didn't distribute that exponent to each one of those things like I did here on this top line. That's wrong. But what I do get to do is I notice that exponent just takes care of that radical, and they just cancel each other out, which leaves me with this. So that's what happens over here on this left side. And this makes this really easy. This x squared cancels this radical out. And so the only thing I have over here is 4 minus 6x. On this side, I have to square both parts. So 2 squared is 4 and x squared is x squared. Now, the radical's gone. I've got a second power, so I've got a quadratic. So again, like always, I'm going to push everything to one side. So I'm going to subtract 4 from both sides and add 6x, which is going to leave me with 4x squared plus 6x minus 4 equals 0. Okay, and then we know when I've got a coefficient out front, I'm always got to multiply that times the last term and try to come up with factors that add up to be this middle term. So 4 times negative 4 is negative 16. Factors of negative 16 that add up to be positive 6. Well, let's see, what could that be? That could be positive 8 and negative 2. Negative 2 times positive 8 gives me negative 16. Negative 2 plus positive 8 gives me a positive 6. So yeah, I feel good about that. So I'm going to split that 6x into those two terms. I'm going to say 4x squared plus 8x minus 2x minus 4 equals 0. I factor both of these. This is the factor by grouping. So factor both of those. I can take a 4x out, which leaves me with x plus 2. Out of these, I can take a negative 2 out, which leaves me with x plus 2. And now I have 4x minus 2 times x plus 2. equals 0. And so then I can set each one of those equal to 0, and to get 4 x minus 2 is equal to 0, which would be to say 4x is equal to 2, so x is equal to 1/2. Or x plus 2 is equal to 0, so therefore x is equal to -2. So those are my two possible solutions. Now, here's the only problem. Before I can get really happy and go, wow, that wasn't hard, I'm all done, is you've got to. Anytime you've got a radical in your problem, you've got to take these solutions and plug them back in because they might not work. See, when you square something, it invites what's called extraneous answers that don't always work. So I could say 4 minus 6, oops, I forgot the 6. Said it, but I didn't write it. Okay, so 4 minus 6 times 1/2, the square root of that equals 2 times 1/2. And let's see this comes out right. So what would this be? 6 times 1/2 is 3, so we get 4 minus 3 equals 2 times 1/2, which is 1. Okay, so 4 minus 3 is 1, square root of 1 is equal to 1, and that is true. So we feel good about that. So x equals 1/2. That is a good answer. All right, let's try the other one. And see if the other one works as well. Okay, and so for this one, we'd have 4 minus 6 times -2. Okay, square root of all that equals 2 times -2. So on this one, we get, let's see, 6 times -2 is going to be -12. So this is going to be like 4 plus 12 equals -4. Well, 4 plus 12 is, that's going to be square root of 16 is equal to -4. Square root of 16 is 4. 4 equals to -4. That is not true. So this right here, this -2 is an extraneous answer. So we don't want that. So the only answer we do want is x equals 1/2. That one we feel good about. Okay? We don't like the other one. And that's what happens. We got to check that. Okay, another radical problem. Let's look at this. So let's think through the system of what we did. I want you to work this one alongside me. Make sure you're getting all of it. First thing we do when we got these problems involving radicals, we square both sides. So I say 3x squared equals, and when I square this side, we know that's really easy. Just cancels the radical out. So those cancel out. This, I have to square both terms. I get 9x squared equals 5 minus 12x. I'm going to subtract the 5 and add the 12x, and so I get 9x squared plus 12x minus 5 equals 0. Quadratics, I'm pushing it all to one side. 9 times -5 is -45. Factors of -45 that add up to be positive 12. That would be positive 15 and -3. So I split this into those two values. And I say 9x squared minus 3x plus 15x minus 5 is equal to 0. When you have four terms, you factor by grouping. So I can take a 3x out, which leaves me with 3x minus 1. I can take a 5 out, which leaves me with 3x minus 1. And so then I have a 3x plus 5 times 3x minus 1 equals 0. Push the 5 to the other side, and you get 3x is equal to -5, so therefore x is equal to -5/3. For this one, you push the 1 to the other side, and you get 3x is equal to 1. So therefore, x is equal to 1/3. So the two answers I have are -5/3 and positive 1/3. So then we come up back, and let's plug those in and see what we get. Okay, so 3 times -5/3 is equal to 5 minus 12 times -5/3. So let's see how this works out. 3 times -5/3 is just going to be -5 is equal to -12 times -5 is positive 60. So this is going to say 5 plus 60/3. And 60/3 is 20. So this is 5 plus 20, which would then be, whoops, forgot an equal sign, equals square root of 25. So this just says -5 is equal to 5, and that's not good. Okay, we're not good with that. And that's where, again, when you square these problems, it's real common. You'll get extraneous answers, and so we want to be on the lookout for those. And so we want to always check our work and make sure we're not just assuming that whatever we got must be right. So then I plug in the 1/3, and I get 3 times 1/3 is equal to 5 minus 12 times 1/3. 3 times 1/3 is 1. 5 minus 12 times 1/3 is 4. So you get 5 minus 4. 1 is equal to square root of 1, which is true. So we like this answer, and this other one is extraneous. Okay, now your turn. One more problem involving radicals, and this one is for you to try. Go through the same basic steps and try to solve it. So we're going to pause the video right here and give you guys a shot. Okay, let's see how you did. Like we said, every time you see a problem involving radicals. Now, the only thing about this one, and I should have mentioned this. I should have thrown a curveball or something like that. If this problem had said 10 minus 18x minus 2x equals 0. Now notice that the minus 2x is not under the radical. If the problem had said that, you cannot just square both sides. Bunch of bad things will happen. Think about it. If I have 10 minus 18, oh, that's supposed to be an 18x minus 2x equals 0. If I square everything over here, I have to FOIL it, okay? Which means I get 10 minus 18x minus 2x times the square root of 10 minus 18x minus 2x, okay? And I have to go first times first, outer times outer, inner times inner, last times last. And so I'm actually going to end up with 3 terms. I'm going to end up with 10 minus 18x, and then because I've got to do this outer, I'm going to get minus 2x times the square root of 10 minus 18x. What a mess. And then another minus 2x times the square root of 10 minus 18x. And so I'm going to get these terms that still have radicals. So even though I squared both sides, the radicals didn't go away. The only way I can make the radical go away is to make sure that the radical is completely by itself on that side of the equation sign. I have got to do that. The only thing that can be on one side of the equation is just the radical, all by itself. That is super important, and I'm sorry that I didn't already mention that. Now, these problems that I gave you, that didn't happen, and so, you can kind of go ignorance is bliss, but there's some problems in the book that I know what they're going to do is they're going to say, hey, this is x plus 3, and then they're going to put like a minus 4 over here and say equals 0. All right, well, the very first thing you would have to do is change this to something like that. Then you can square both sides and get this, and then you can get something like that. And then all of a sudden now you're good to go. But had you squared it on both sides up here, that would have been hideous and would not have worked. Okay, sorry. Should have mentioned that earlier, but at least it's out there. Okay, so let's look at this one. First thing we're going to do, square both sides because the radical is by itself. So that's going to give me 10 minus 18x is equal to 4x squared. Push everything to the same side as the 4x squared. So I have 4x squared plus 18x minus 10 equals 0. 4 times negative 10 is negative 40. Factors of negative 40 that add up to be positive 18 would be positive 20 and negative 2. So I'm going to split that 18x into those two values and say plus 20x minus 2x minus 10 equals 0. The first one, I can take a 4x out of both terms, which leaves me with x plus 5. Next one, I can take a minus 2 out, which leaves me with x plus 5. And so now I have 4x minus 2 times x plus 5 equals 0, which would mean 4x minus 2 equals 0. So that would be 4x is equal to 2, x is equal to 1/2, or x plus 5 is equal to 0, so therefore x is equal to negative 5. Now I go back up and plug those in. I don't know if you guys have noticed the pattern, but the negative one usually doesn't work out. So this one, we could expect that to be the extraneous answer. Okay, this one I'd have 10 minus, let's see here, 18 times a negative 5 equals 2 times negative 5. Okay, in this case, 18 times 5 is 90. They're both negative, so that makes this thing positive. 10 plus 90 is equal to 2 times negative 5 is negative 10. This ends up being square root of 100 is negative 10, and this says 10 is negative 10, so that's no good. So again, this is not the good answer. We can expect like the other one is, but because we're good math students, we're going to check. So we're going to say, okay, square root of 10 minus 18 times 1/2 is equal to 2 times 1/2. Now, isn't it funny that all these have come out to where it's 1 equals 1? That's kind of lame. But anyway, this becomes 10 minus 9. Square root of that equals 1. So square root of 1 is equal to 1. Therefore, 1 is equal to 1. We feel good about that. So this answer, x equals 1/2, is great. All right, just a couple more to go. Okay, so the next one in the homework looks something like this. And that might have freaked you out and you thought, man, that's hideous. But ultimately, this is a quadratic-ish problem that, okay, the last one involved radicals. This one involves substitution. Now, we've done problems like this already this year, but we were just trying to factor them down to something simpler. They were an expression. They weren't an equation that we solved and actually got answers. They were just expressions that we're trying to simplify down. But this one, we're going to use a little bit of substitution, and we're going to try to get an actual solution to this. So what I'm trying to see right here is that I look and go, I see if this was some like an A, and this was an A, look what this would actually rewrite to be. This would say a squared minus 6a plus 8 equals 0. Now right there is a very basic quadratic. That's a really simple one. And ultimately, that's kind of what we have. It's just a whole lot uglier, okay? And so what we're going to do is we are going to do some substitution. So over here, I'm going to say, hey, let's let u equal 1 plus 1 over x. So then when I rewrite this, I get u squared minus 6u plus 8 equals 0. Now, that's really easy. Factors of 8 that add up to be negative 6 would be negative 4 and negative 2. And then I can solve that and get, well, u minus 4 is equal to 0, so therefore u is 4. Or u minus 2 is equal to 0, so therefore u is 2. But I'm not done. Because I did this substitution, I have to re-substitute. So now I'm going to take this and say, well, if u is 4, but u is 1 plus 1 over x, that's equal to 4. I can subtract 1 from both sides. I get 1 over x is equal to 3. I can multiply both sides by x. Get 1 is equal to 3x. Divide both sides by 3. And x is equal to 1/3. And that's the solution. But then I have to do the other one as well. The u is 2. I say 1 plus 1 over x is equal to 2. Subtract 1 from both sides. 1 over x is equal to 1. Multiply both sides by x. 1 is equal to x. And so that's the other solution. X is equal to 1. Okay? So those are my two possible solutions. With this one, because I did not do any squaring, I don't have to worry about extraneous answers. The only thing I have to double check is just make sure that both of these are acceptable to plug in. And you can see that because neither of these solutions are 0, then both of them are acceptable to have in that denominator. So we're good. Okay, let's try another one. This one, again, I'm hoping you can follow along with this one, and then in just a second, I'll have you do one by yourself. So with this one, again, we have something here squared, and then we have a constant times that same something, and then we have a constant. So this really does look a lot like a quadratic. So I'm going to start by saying, well, let's let u equal x minus 2. So then this would be rewritten, u squared minus 7u plus 10 is equal to 0. Okay, well, factors of positive 10 that add up to be negative 7 would be negative 5 and negative 2. So we get u minus 5, u minus 2 equals 0. So therefore, u minus 5 equals 0, u would be equal to 5. And if u minus 2 is equal to 0, then u is 2. And then we plug that back in, and so we get 5 is equal to x minus 2. Add 2 to both sides, and x would have to be 7. Or we get 2 is equal to x minus 2. Add 2 to both sides, and x is equal to 4. So those are the two possible solutions that will make this work. Okay? We did a little bit of u substitution to make this a much easier looking quadratic that then we could factor. Once we get solutions for our new substitute variable, we plug in what we set the variable equal to, and then we solve. Pretty easy. So now there's one for you to try. Here you go. I know it looks wild and crazy, but it is no harder than any of the other problems. So we're going to pause the video right here, give you guys a shot at this one, and see how it goes. All right, let's see how you did. Okay, clearly this is the thing that shows up a couple times that I need to substitute. So I'm going to say, let's let u equal 1 over x minus 1. Now, is that the exact same thing we had before? No, we had 1 plus 1 over x. Sorry, I couldn't remember. All right, so then this would say u squared plus 3u minus 18 equals 0. Factors of negative 18 that add up to be positive 3. Well, that would be positive 6 and negative 3. So we're going to say u plus 6 times u minus 3 is equal to 0, which would mean u plus 6 is equal to 0, or u is equal to negative 6. U minus 3 is equal to 0, which would mean that u is equal to 3. Okay, so u is equal to negative 6 and u is equal to 3. Now we're going to take those solutions and plug back in, kind of resubstitute. So we say negative 6 is equal to 1 over x minus 1. Now to get that variable out of the denominator, we're going to multiply both sides by x minus 1. These cancel out, and over here we'd have to distribute. We get negative 6x plus 6 is equal to 1. Subtract 6 from both sides, we get negative 6x is equal to negative 5. Divide both sides by negative 6, and we would get x is equal to 5, 6. So that's one of our solutions. The other one, we have to use this 3. Okay, I'm going to scoot everything over just a little bit. Okay, give myself a little room and say, well, we could have 3 is equal to 1 over x minus 1. I'm going to multiply both sides by x minus 1. Distribute over there, we get 3x minus 3 is equal to, these cancel out, 1. Add 3 to both sides, we get 3x is equal to 4. Divide by 3, and x is equal to 4 thirds. All right, and that's what I have. So my two possible solutions are x equals 5, 6, and x equals 4 thirds, both of which are fractions, and so we don't love those, but we didn't deal with the fraction until we get to the very end. So it was a pretty simple problem, okay? Not bad. So very first one is we had quadratic problems, but they had too many powers. We had to factor something out. Second one we had were quadratic problems, but they were involving radicals. Third one is quadratic problems involving a little bit of substitution. Okay, and now lastly, we have quadratic problems involving fractions. So this is what number 4 looked like on your homework, and hopefully you had an idea of how to do it. We've talked about it before. We said anytime you have fractions, you could find a common denominator. In this case, the common denominator is x times x plus 2, and you'd multiply everything by this common denominator. And that's what makes fractions go away. So we get 3 times x plus 2 all over x plus 5 times x plus 2 all over x plus 2 equals 2 times x plus 2. And we can just kind of walk right through. Here the x's cancel out. Here the x plus 2's cancel out. And on the last thing, nothing cancels out. Okay? So on this first one, we can distribute the 3. We'd have 3x plus 6. On the second one, we just have 5x. And on the last one, we'd have 2 times x would be 2x squared. And 2 times x times 2 would be plus 4x. Now we've got a quadratic, but just like before, we've got to push everything to one side or the other. So I like having my squared term positive, so I'm going to push everything to that side. So I've got 2x squared, I've got 4x, and I take away 3x, so I've only got 1x. Take away 5x, and I've got negative 4x, and then minus 6 equals 0. Okay, for these, we say, well, 2 times negative 6 is negative 12. Factors of negative 12 that add up to be negative 4 are 2 and negative 6. So that's pretty easy. So we get 2x squared minus, let's say we'll go plus 2x minus 6x minus 6. And this should be really easy to factor. Okay, you can take a 2x out of each one of those, which leaves me with x plus 1. We can take a negative 6 out of these, which leaves me with x plus 1. So you get 2x minus 6 times x plus 1 equals 0. So then you would have that either 2x minus 6 is equal to 0, which would mean that 2x is 6 and x is 3. Or you can have x plus 1 equals 0, which is that x is equal to negative 1. Okay? Now, the only thing you have to do is just double check that both these solutions are okay. Would any of these solutions cause an undefined situation where you'd have 0 in the denominator? And no, the only number that we can't have, or the numbers, are 0, x cannot be 0, or x cannot be negative 2, because that would make the denominator 0. So I don't have a 0 or a negative 2, so I'm good. My solutions are x equals 3 and x equals negative 1. All right, let's try it again. Now, we'll go a little bit slower. But this is a pretty simple problem because there's only one fraction. So I'm going to multiply through by that denominator. That's my only denominator. So I'm going to say 10 times n plus 5 over n plus 5 plus 15 times n plus 5 equals 3m times n plus 5. Well, clearly in the first one, these cancel out. I'm left with 10. In the second one, I distribute. 15m plus 5 times 15 is 75. And the last one, distribute. 3m times m, 3m squared. 3m times 5, 15m. Okay. Well, the 15m's just cancel out. I got a positive 15m on both sides. They're gone. All right. So I have 3m squared is equal to 10 plus 75 is 85. All right. Let's see. What can I do? Well, this doesn't factor down very nicely. I can subtract the 85 from both sides. I get 3m squared. Let's see. I just want to make sure I didn't make any obvious mistake. No, I think that's right. 15m, yeah. Just want to make sure I was looking at this right. Minus 85 is equal to 0. This is real hideous at this point, but, you know, c'est la vie. So, honestly, I'd use the quadratic formula to solve it, realizing that this is the same as 3m squared plus 0m minus 85 equals 0. Wow. This problem came actually straight out of the book, so I'm surprised it got so ugly. It's possible that I made some small error that I'm not seeing right now, but I'm trying to go back through my work and double check, and it looks like everything is there. 3m squared, 3m is 15m. Yeah, I keep looking through it. But anyway, so with this one, I could say that m is equal to negative b, which is 0. So you have negative 0 plus or minus the square root of 0 squared minus 4 times a, that's 12. 12 times negative 85 is a big number. Negative 1020. So it would become plus 1020 all over 2a, which would be 6. And so this whole thing just equals the square root of 1020 over 6. All right? And it would be the plus or minus of that. Sorry. And so those are your two solutions. Pretty hideous, but either way, it's true. All right, let's look at the next one. So now here's one that's not too hard. It's not too challenging. You guys should be able to do it. You can clearly see what the common denominators are. The common denominators are x plus 3 times x plus 4. All right, and so if you multiply through everything by x plus 3 times x plus 4, all the fractions will go away and you can solve. So we're going to pause the video right here and give you guys a shot at this one. Go for it. All right, let's give this a shot, okay? So at this point, what we're going to do is we say, I'm going to multiply everything by this x plus 3 times x plus 4. All right, and so that's going to mean this first one's going to be 1 times x plus 3 times x plus 4 plus 2x times x plus 3 times x plus 4 all over x plus 3 times x plus 4 equals 2 times x plus 3 times x plus 4 all over x plus 3. And I need to scoot everything down. Plus 4 times x plus 3 times x plus 4 all over x plus 4. All right, now let's cancel a bunch of things out. These all cancel out. Over here, the x plus 3's cancel out, and over here, the x plus 4's cancel out. So we can rewrite this. And right here, you know, we FOIL that, and that becomes x squared plus 7x plus 12 plus 2x equals 2 times x plus 4 would be 2x plus 8. All I did was distribute that 2 to the x and the 4. Okay, plus 4, we distribute that, we get 4x plus 12. All right. And what we're going to do, because we got a quadratic, is we're going to push everything to one side. And this is where it's going to be easy to make a mistake. So it might be easier to combine like terms on each side and then push everything over. Like this side would be x squared plus 9x plus 12 equals, and on this other side it would be just 6x plus 20. A lot easier maybe now. So subtract 6x from both sides, we'd have x squared plus 3x, subtract 20 from both sides, and we would have minus 8, right? Equals 0. Once again, we get a quadratic that does not come out clean. Sweet, because once again, this problem came from the book. So I'm just going to go, well, x is equal to negative b plus or minus the square root of b squared, 3 squared, minus 4 times a times c, which is going to be 4 times negative 8 is going to be plus 32 all over 2a. So this is x is equal to negative 3 plus or minus 3 squared is 9 plus 32. It's just 41. And there you go. And it might not be pretty, but it's still your answer. And everyone should be able to do this. Okay? And so here's what I need you to do. Just because you get to a situation where you go, oh man, I thought it was going to come out so clean, and it didn't, that doesn't mean you're wrong. You got to just keep rolling, and you can use the quadratic formula. All right. I hope this was helpful. If you need to, you can rewatch any parts of this video, but what I'm going to do is have you get working on some problems in some small groups, and hopefully you can make some sense of them. All right, I'll see you guys on Wednesday. Have a great day.